This last video is again for section 2.3, which is about properties of functions. But I'm going to talk this time about the average rate of change of a function. Average rate of change of a function from one x value to another x value. We'll call those x values a and b. The first thing I'm going to do is draw like a generic function, putting two x values, a and b, on the x-axis, and two f values. We'll call this one f of a and f of b. Our function is going to have a value at a f of a and b f of b, and it's going to kind of wave through like that, two endpoints. Okay? The average rate of change is defined as the slope of the straight line. It doesn't look very straight, does it? Let's get rid of that. Let me draw my function again. And then draw a straight line from a to b, and f of a to f of b from these points. The slope of the line, which is really not part of the function, is what the average rate of change of a function is. Basically, it's how quickly the function changes as x moves from a to b. Right? So since it's the slope of that line, it's the rate of change of that line, and it's average, meaning it's approximating the change of the function from between 2 points, the formula for the average rate of change is going to look very similar to the slope formula. You take the difference in the y-coordinates of the 2 points, so f of b minus f of a, and divide that by the difference in the two x-coordinates of the points, b minus a. Notice its similarity to slope. One thing to be very careful of: if a question asks you to find the average rate of change of a function from x equals a to x equals b, notice that in the formula you start with, in both the numerator and the denominator, coordinates for b, which is the second thing mentioned in the question.